Hello and welcome to this introduction to programming for biologists. In this tutorial, we'll be discussing the role of programming in biology and exploring some of the top programming languages used in this field. We'll also provide a roadmap for those who are interested in learning programming at the foundation level. And we'll discuss some of the career prospects available to those with programming skills in the field of biology. So, what is programming? Programming is the process of creating instructions for a computer to execute. It is a crucial skill for scientists and researchers in many fields, including biology, as it allows us to analyze and interpret large amounts of data and to develop custom software and databases for our specific research needs. Now, let's talk about the top 10 programming languages used in biology and bioinformatics. These include Python, R, Java, C, C++, Perl, Ruby, JavaScript, MATLAB, Haskell, and Julia. Each of these languages has its own strengths and is well suited for different types of tasks. Python, a popular language for scientific computing and data analysis with many libraries and tools for working with biological data. R, a language and environment for statistical computing and graphics widely used in the analysis of biological data. Java, a general-purpose language that is popular for developing large-scale software applications including many bioinformatics tools. C, C++. These languages are widely used for low-level programming and for developing high-performance applications including many bioinformatics tools. Perl, a flexible language with a large number of libraries and tools for working with biological data including text processing and regular expressions. Ruby, a general-purpose language with a focus on simplicity and readability, often used for developing web-based applications and tools. JavaScript, a popular language for developing web-based applications, including many bioinformatics tools. MATLAB, a proprietary language and environment for technical computing with many built-in functions and libraries for working with biological data. Haskell, a functional programming language with a strong type system, often used for developing bioinformatics tools and algorithms. Julia, a relatively new language specifically designed for scientific computing and data analysis with many libraries for working with biological data. These are just a few examples, and there are many other programming languages that are used in the field of biology and bioinformatics. If you are interested in learning programming as a biologist, a good place to start is by choosing a language that is commonly used in your field. Then you can follow a roadmap like the one we have outlined here. Install a programming environment. Learn the basics of the language, including concepts such as variables, data types, loops, and control structures. Practice by applying what you have learned to small projects of your own. Learn how to debug your code. Keep learning and staying up to date with new languages and their features with their technologies. Now, let's discuss some of the career prospects available to biologists with programming skills. These may include positions such as bioinformatics researcher, data scientist, computational biologist, software developer, research programmer, database administrator, scientific programmer, technical support specialist, data analyst, research assistant.